Now in this section, let's look at complex conjugates theorem. It's very similar to the irrational conjugates theorem. So what this says is pairs of complex numbers of the forms a plus bi and then a minus bi, where b is not 0, are called complex conjugates. So conjugates are where they're the same terms but opposite signs in the center. So we have a plus bi and then a minus bi. If a polynomial function with real coefficients and you have a plus bi is an imaginary 0 of f, one of the solutions of f, then a minus bi is also a 0 of f. So what we're going to do is we're going to write polynomial functions, right? And they are going to have real coefficients. So in order to have real coefficients, we would have to have complex conjugates in order for the I to disappear. So for example, this would be a squared. Remember, this is the pattern a minus b times a plus b. So this would be a squared minus b squared. So this would be a squared minus b squared I squared, or this is a squared minus b squared times -1, which would be a squared plus b squared. Okay, so notice there's no more I in here. So try an example. Write a polynomial function f of least degree that has rational coefficients and a leading coefficient of 1. And the zeros are 2 and 3 plus I. So remember that it's saying that we have x-intercepts at x equals 2 and x equals 3 plus I. And so much like the irrational conjugates, remember when we write this as in factored form, this would be x minus 2, then the other one would be x minus a 3 plus I, and then because the conjugate, we need the conjugate as well, that would be x minus a 3 minus I. Okay, and that is our initial function. Okay, then we have to simplify it so we can find what is the polynomial function. And so it's just the same like the other one. So what we're going to do is we're going to regroup so that we have our x minus 3 together plus I, and then we have our x minus 3 and then minus I together. Then this is our a plus b, a minus b pattern. So let's simplify this. This is x minus 2, and then the first part, our a, is x minus 3 raised to the square minus I to the square. Okay, and then we remember that I squared equals -1. So simplify this further. X minus 3, we need to expand that. And remember that pattern. X minus 3 squared is the same as x minus 3 times x minus 3, which is also our a minus b squared pattern. Okay, so this would expand to x squared minus 6x plus 9. And then don't forget to bring down the negative I squared. So that's -1. Simplify further, x minus 2 times x cubed minus 6x. This becomes a plus 10. Then we need to multiply it through. So I'll go ahead and do the box method. X and -2, x squared minus 6x into 10. This is x cubed minus 6x squared, 10x. -2x squared, this is 12x, and -20. And if we simplify all the way, our function would be x cubed minus 8x squared plus 22x minus 20. And notice again, this is with a function of least degree, has rational coefficients, there are no i's in there, and a leading coefficient of 1. So go ahead and try out these next two examples, pause the video, and then I'll give the answers when you come back. Okay, so first of all, to set this up, this would be x plus 1 times x minus 4i times x plus 4i. Okay, then when you finish this out, this one would be x cubed plus x squared plus 16x plus 16. The second one, you would write that as x minus 3 times x minus 1 plus I root 5 times x minus 1 minus I root 5. Okay, so that's number one, how you would set it up with the parentheses, then regroup and everything else. This final answer would be x cubed minus 5x squared plus 12x minus 18.